Okay, class, this is my recording for chapter 3.5. We're going to take a look at an example of implicit differentiation. I'm going to show you this function. 4xy plus 2y is equal to 6x at the point 1, 1, which is on this curve, by the way, and we want to find dy dx. So here's the problem. Keep in mind that implicit differentiation is really most helpful when you have a function that cannot be expressed explicitly. In other words, it cannot be easily solved for y. Okay. Now, this means that when we take the derivative here, we do have one product rule. And every time that you differentiate a y term, you must write the differential y prime. Okay, so it's going to be a product rule first times the derivative of the second. The derivative of y is just 1 times y prime plus the second, which is y, times the derivative of the first, which is 4, plus the derivative of 2y, which is 2 times y prime, and that's equal to 6. So this is my raw derivative. Now, again, my language is the raw derivative. That's my very first step where I've used my product rule and I've taken the derivative and I've written y prime wherever I have differentiated a y term. Now I have to use some algebra to solve for y prime. So I'm going to move some things around here. So on the left-hand side, I still have, or I'm going to have, 4x times y prime plus 2y prime is equal to 6 minus 4y. So I'm just gathering some things together, and I'm going to try to solve for y prime by now factoring out a y prime from those two terms. Last step will be to divide. Okay. Now, one of the big differences here, when you do find the derivative, in order to be able to actually find the rate of change, the slope of the tangent line, you have to plug in both an x and a y. That's why I'm telling you that that point 1, 1 is actually on this curve. So now I have y prime times 4x plus 2 is equal to 6 minus 4y. And my last step will be to divide. So let me show you this. Okay. Last step will be to divide now by that term just to the right of the y prime. So I'm dividing by 4x plus 2, and on the other side by 4x plus 2. On the left-hand side, it cancels out. So that means that my y prime is equal to 6 minus 4y divided by 4x plus 2. Now, it's true that I could reduce this, but that really is not necessary. Although Weber's sign might be kind of fussy, but that's my derivative. That's y prime, which is, by the way, dy dx. Now, if I wanted to actually evaluate what the rate of change is, in other words, if I wanted to evaluate what the slope of the tangent line to this curve is, and by the way, this is not a function probably. But you could graph it if you wanted to in Wolfram. I would plug in the 0.11 and I will find that f prime of 1, 1 is equal to 6 minus 4, which is 2, divided by 4 plus 2, which is 6. And reducing that, I get the slope, or m, of the tangent line. The slope of the tangent line is actually equal to a positive 1/3. All right, now that's an entire example. It's just one example, but certainly there are others that you can look at in the textbook. If you have downloaded the chapter review documents, there will also be some YouTube videos available on those that you should watch. Okay. And I'm going to end this. And this takes us to right about where you should be, about halfway through this chapter 3. All right, stopping the recording.